So we need to show that this function here, up there, can be differentiated into this. This will require a quotient rule because we've got a rational function with a polynomial in the numerator and a polynomial in the denominator. So we will let u become the numerator polynomial. U dash will therefore be 2x. V make 2x plus 1. And v dash is equal to 2. And the formula for dy dx, for it's a quotient rule, needs to be u dash v minus uv dash over v squared. These two terms will be multiplied and these two terms will be multiplied. So we will get 2x multiplied by 2x plus 1. Take away x squared plus 6, and it's important that you put this into the brackets, multiplied by 2, and we divide it by 2x plus 1, which needs to be all squared. And if I distribute the first part, I'll get 4x squared plus 2x. And if I distribute the 2 in the next part, I'll get 2x squared plus 12. And I was careful to still keep it in the brackets. Now that still goes under 2x plus 1 all squared. Now we take the brackets off. And we're left with exactly what they want, which is 2x squared plus 2x minus 12 over 2x plus 1 squared. And this is our gradient function. And this gradient function is able to tell us the slope in this original function at any value of x. And where to find out at what value of x will that slope be 0. So when we make that slope equal to 0, that means that 2x squared plus 2x minus 12 over 2x plus 1 all squared must be equal to 0. And that would really mean that this numerator must be equal to 0. As we make that 0, the whole equation is 0. And so we're only interested in the numerator being 0. Now this is a quadratic expression where I can see that 2 is a common factor, so I can divide the whole expression by 2. And you may want to factorize it using quadratic formula, or you can just factorize it by noting that minus 6 has 2 factors, and that could be 2 and 3. So it may either be 2 or minus 3 or minus 2 or 3. And it seems that in this case, to get 1, we will have x minus 2 and x plus 3. And so this equation only makes 0 if x is equal to 2 or x is equal to negative 3. So when x is equal to 2 or x is equal to minus 3, our dy dx is equal to 0. What does that mean? It means that there are tangents are horizontal, or you can say that the slopes at these 2 points are horizontal. And for what values of x is dy dx undefined? If you look at that gradient function again, you'll notice that the only time that this function will be undefined is when this denominator is 0, because we cannot have an equation with something over 0. So we will look at 2x plus 1 all squared. If this is 0, then this whole equation will be undefined. When will it be 0? Okay, when 2x plus 1 is equal to 0. So that means 2x is equal to minus 1 and x is equal to minus a half. So at x is equal to minus a half, the function is undefined. I would like to demonstrate this for you by showing you the graph from the Desmos. Okay, we calculated that dy dx is equal to 0 at x is equal to 2 and at x is equal to minus 3. And looking at this function that we have just seen, you might be able to see that that's exactly where the tangent is 0 at that point 2, and it is also 0 at the point 3, minus 3. And we calculated that the dy over dx is undefined at x is equal to negative a half. So if I was to draw a line this way, you'll notice that that graph does not touch that particular line. And this line is called the asymptote. Well, thank you for watching this. And if you found it useful and helpful, then please subscribe to this channel and there'll be more videos coming like this.